Okay, today we are starting our revision class. I will do more theory revision using screen sharing and fast paper discussion through whiteboard. Okay, all right. So now the first chapter is mechanics, and in that we will study about linear motion today. Okay, so linear motion is the easy part. You get questions from it consistently. There will be one or two questions in the MCQs, and essays also you will get questions. Guys, sometimes you might think that you know the thing, you know clearly what's expected from you. You might think that you are 100% doubtless about a particular topic. But when it comes to exam, when some questions come, then only you realize that there are some gaps in your knowledge. So that's a real problem. So you need to have somebody who is telling you about the gaps in your knowledge before you go to the exam. During the exam, if you realize the gaps, there is no use. That's actually your bad luck that you're realizing at that point. So you need to have constant feedback from someone to understand the gaps in your knowledge so that you can fill. If you don't understand in the first place, then you can't fill. There is nothing to fill. So you need somebody to point it out and give you feedback. Okay, so that's what they say. Uh, that's what they imply when they say practice makes you perfect. People say practice makes you perfect, right? So the real meaning is you study something, you practice it several times, and then you should get immediate, not immediate, most of the times it's early feedback, not a late, delayed feedback, like your results come. You don't have feedback then and there. After some time only you understand, okay, these are the things that went wrong. So you need some immediate or at least early feedback. That's what we are going to do in the revision class. I am going to be the person who is going to help you identify the gaps in your knowledge and fill it by giving feedbacks. We will go from scratch. Okay. We are not going to underestimate anything. From the basics, we are going to revise everything, and there will be enough time for you until the exam to revise and practice well. Okay. So you are going to practice several times. Repeated practice always works. Okay. And because it's the first class, I'll tell you a very important study tip that I used when I was an A-level student. Okay. I got 46 out of 50 in my physics MCQ. Okay. And I got All Island second rank in 2016. I'm just telling you in case if you don't know. Then only you will trust me that my methods are actually uh, evidence based. Okay. Now, what I used was I study the theory just to make sure that I understand properly. What I do is I write on a paper and explain every theory to myself. So when you explain something, you are kind of an expert. Only a person who has understood something fully can explain it in their own words. Otherwise, they can't do that. So you have to study by active learning. You have to actively teach it to yourself, write it on a paper and study. And then what I do is I did practice questions. Practice quiz, I used SR Kumar. I study in Tamil medium. So I used SR Kumar's books in order to cover the practice questions. So it will be like, for example, the questions will be like, okay, Here object starts at time t is equal to 0. Here time t is equal to 5 seconds. Let's say the acceleration is 5 ms minus 2. So what is the distance traveled? What is the final velocity? So questions like that. When you practice very basic questions and end up doing difficult question in a graded fashion, that tells you that you have understood the topic and you will never forget those equations for the rest of your life, at least until you write the exam. Next step is doing the past paper and finding correct explanations for past papers. I did from sorry, 1979. But we are going to do from 1992. Still, it is more than 30 years, right? So if you do like that, they are going to definitely repeat some of the questions so you can score more than 40. Okay, in MCQs. Past paper, not only MCQs, but structure essay. And I used to read Rosas's books just to make sure that I'm getting the questions correctly. Sometimes you know the correct answer, but you might be understanding it differently than the actual compared to the actual explanation. So you have to make sure that you are in the same page as the what I mean is that you understand the question the same way as the people who made the question understood. Okay, so that kind of understanding is required. So that's why we study Rosas's past paper explanations. Because I have studied that, I am going to explain all the questions according to his method most of the times. But if you can read, that is also better. But I'm not sure whether you'll have time. But for the new sections you are studying, you have to go through all these steps. You have to read. Okay, I mean, what are you studying in your theory now? Can I ask that question? What are you studying? Can one of you tell me? Hmm? Hello? Can one of you tell me what do they teach in your theory classes? You are studying G field. So for G field, D field, for the future chapters, you have to do uh, all these steps. All right? Yeah. Then what I did was, past paper and then some model papers, only if they are very standard model papers and with answers. Without answers, you will not have feedback. So you need to have that uh, answer thing always. All right? Okay. So this is the way that we are going to study here. I'll explain you a theory, revise you the theory in exam-oriented way. We will study only the things that are required for your exam. And then we will practice the questions from the past paper, mainly the MCQs. Here and there, for the practicals, we will do structures and some of the essays. Okay, because when we start to discuss the essays completely, the time will never be enough. Okay, so I'll discuss only some of the essays in each topic. Okay, then model paper exam will be there and we will make it a common exam. No, those who come to the classes and those who don't come to the classes can participate so that it will be more competitive environment. Okay, and the time frame is up to next year, July or June. We will try to cover the full theory. Okay, all right. Yes, so now we will start studying linear motion. Okay, so linear motion is the motion of an object that happens in a straight line. Okay, in a straight line. That's what's meant by linear. Okay, there is a special type of curvilinear motion, curved but still can be described as linear motion. But we will just talk about the ones that are in the straight line. Okay. First, you need to understand the definitions. Okay. So let's say that there is an object like this. Okay. and it's going to travel this way. Okay, let's say that it is traveling at a uniform velocity. Okay, it's traveling at a uniform velocity. So here time t is equal to t. Here time t is equal to 0. Okay, in between it will travel some distance. Let's say s. Displacement is the direct distance from the initial point, the shortest distance from the initial point. Okay. So now remember, when you're measuring displacement, which is a vector, you need a reference point. We are considering this point as the reference point. Therefore, here the displacement is 0. And in this direction, the displacement is increasing. Okay. And students, you have to decide the sign. Okay. You have to decide the sign. So from this reference point, if I take the right side as plus and the left side as minus, that's how I'm going to describe the direction of displacement. So I already told you that it is a uniform velocity process, right? Movement. So if I try to draw a displacement time graph, how will it look like? Can you take a rough sheet and draw? Okay. So now initially it's 0. So you know that it should start from the origin. And then it is increasing in this direction, which we are considering as positive. Which we are considering as positive. So in that direction, displacement increasing. Because it's a uniform velocity, the graph will be uniform. In the sense, the gradient will be constant. I'll explain about the gradient and all, okay, later. But now, just know that this is the graph. Okay. Now look at this example. Here, this is the path. This is the reference point. I have marked here as displacement equal to 0. Now the object is starting the motion from here. Okay. At time t is equal to 0. And at the end, it reaches this point. There the time t is equal to t. Okay. Now, can you guys try to draw a graph for this? Take your rough sheet and draw. Uniform motion, uniform velocity is there. Okay, assume that there is a uniform velocity throughout the motion. So now draw the graph, will you? Okay. So now, here you need to have idea which direction you are going to take positive. Okay. So I mean, I could have told you just to get same answer for everyone. But I hope most of you took right side as positive and left side as negative. Okay. If you have taken like this, okay, initially from this reference point, the object has a positive displacement at time t is equal to 0. And then it moves, and then at some point it will come to displacement 0, and then it will go to the negative direction. Displacement will increase in the negative direction. So here the graph is going to be like this. Or if you have taken the other way, students, right side as minus and left side as positive, it would have looked like this. Okay, I'll just give a small thing in a side. In case if you have taken the directions the other way. Okay. Now, do you have any questions here? Hmm? So now, if I tell a statement like this, here, the direction of the displacement has changed. Is that correct? Can you just unmute and answer? Because none of you know others, right? So therefore, you can just freely talk. Mariam, if I say that the direction of the displacement has changed during the motion, is that correct? Jyotipa, is it correct? When you say the direction of displacement has changed, that is correct. Initially, it's positive. At this point, the direction of the displacement changes. So that statement would be correct. If you say another statement like the direction of the velocity has changed, the direction of the velocity has changed. Is that statement correct? That's actually incorrect. Velocity is the direction of the motion. Okay. So it's always towards this direction. It never went in right hand direction. The motion was not changing its direction. Remember, velocity is about the motion. Okay. But displacement is about the position. Right side plus left side minus relative to the reference point. For velocity, there is no reference point. There is a reference direction. Towards the right side, if you take as plus, towards the left side, you will take it as minus. Okay. So when we study more graphs, you will understand. But because it's only the theory revision, we will just go to the next topic. Okay. If you have any questions, you can ask me. Okay. So when it comes to definitions, so first displacement means, okay, displacement means the shortest distance between the final and initial points. Its direction is described in terms of reference point. Okay. Velocity is the rate of change of displacement. Then the next term is acceleration. That is the rate of change of velocity. Okay. So you can read about it if you want from your notes if you have forgotten. Okay. Now I'm going to explain you the equations of linear motion. Here I have given a velocity time graph. This graph is going to help us prove all the equations that we study in the linear motion. There are only 4 standard equations that you can use directly in essay questions. MCQs, if you are using any even shortcuts, nobody is going to penalize you, but um, only standard equations can be used in the essay. Uh, I think you know that, of course. Okay, now this is a velocity time graph. The gradient of the graph, gradient means y difference divided by x difference. Gradient will give what? Anybody? Gradient of the graph, velocity time graph will give what?
Acceleration.
Very good. Acceleration. area under the graph will give
Displacement.
very good displacement. Okay. Now, now we are going to just derive equations. So for acceleration, I can say the gradient, right? So here when you are calculating the gradient, it's about y difference divided by x difference. Y difference is v minus u. To measure this, you are going to just subtract u from v. So it will be a is equal to v minus u and x difference is t. Okay, then you can say at is equal to v minus u, and then you know v plus v is equal to u plus at. Okay, okay, all right. Now, for area under the graph, we say displacement. Displacement is S. S is equal to area of this trapezium. Okay, area of the trapezium. So what you do is it is sum of the parallel sides divided by 2 times t. So this itself is a standard equation. So here you are relating only few parameters, right? You want an equation without time, and you want an equation uh, without acceleration. Sorry, without final velocity. So what you do is you substitute. Okay, if you substitute for v here, okay, it will be like s is equal to, for v you can put u plus at plus another u is already there into t divided by 2. If you just solve it, you will get ut plus half at squared, which is a standard equation. And from this equation, you can say t is equal to v minus u over a. If you substitute that here for t, okay, you will get s is equal to v plus u over 2 into, for t you can put v minus u over a. Okay, so if you solve it, you will get v squared equal to u squared plus 2as. So these are the standard equations, and you should study it like this. Okay, but anyway, you have to remember this. And you need to do questions on this. I tried to make some practice questions, but you know, I think it's not useful now. If you want, you can do practice questions that your sirs would have given. But if you want, just ask me. I will prepare some and give. Okay. But now, for some of you, it might not be the time to start practice questions. Okay. Now I have some questions for you. Okay. Okay. So just to summarize, v is equal to u plus at. S is equal to v plus u over 2 into t. Is equal to ut plus half at squared. V squared equal to u squared plus 2as. Now, this is a question for you. Okay, so this is a building of height h. From the top of the building, an object called B is thrown with a vertical downward velocity u2, and an object A is thrown from the bottom with vertical upward velocity u1. Now derive an equation for the time taken for the collision of these two balls. Can you do that? The answer should be in terms of the given parameters. Okay. Yeah, do that, do that. So naturally what you should do is you have to derive equations for them separately, right? I'll give you 1 minute. Okay, now for A, you're going to use the equation upwards. So you don't know, they will collide at some point, okay? And we will take, A would have traveled a distance x before the collision, so B would have traveled a distance h minus x. For A, if you use s is equal to ut plus half at squared, okay? It will be x equal to u1 t, okay? T is the time taken for the collision, plus half. A is what, students? It's a free motion under the gravity. So it's gravitational acceleration, right? So we will call it G usually. And gravitational acceleration is always downwards G. When you're using the equation upwards, you have to put minus G into T squared. Okay? Some of you would have put plus. So it's the time that you correct such mistakes. What you get is x is equal to u1t plus, sorry, minus half gt squared. It's going to be my equation 1. Okay. Then for B, downwards, I'm going to use s is equal to ut plus half at squared. S is h minus x, u is u2t plus half. G is already plus downwards, right? So half gt squared. So I can tell you an advice. When you put the direction in the beginning itself, it's easier for you to avoid missing the plus minus. Okay? You will not miss what I'm saying. So it's h minus x equal to u2t. I mean, it's already an equation, right? So this is my equation 2. Now I can solve these two equations. What can I do? Anybody? To add?
Substitute x.
Now if you add 1 and 2, x and minus x will be gone. So you'll have h. This one and this one will add u1t plus u2t. And this will be cancelled, right? Minus and plus, right? Minus half gt squared and plus half gt squared will cancel. So t is equal to h divided by u1 plus u2. Okay. Okay, students, you have to be very familiar with the equations and you have to believe that you can do somehow whenever they ask any question. And you should be very determined when you are answering questions in your exam. You can't stop in the middle. You have to find a solution. With that mindset only, you can score high in essay questions. Okay, you grind, and grind, something will come. Okay, you don't stop. That's how I used to do. I somehow write some equation, somehow not understanding anything about the question, I'll write something and find the answer if you don't know the answer. You have to have that determination. Okay. Practice that from the past papers by doing the past paper. For essays, don't do any model papers, just do the past papers. Okay. Now, this question, can you answer? You can write it down. Okay, I'll give you some seconds. If you have written, you can try this. Okay, this question, an object is projected upwards with a velocity 100 from the ground. If the air resistance is neglected, it will strike the ground in. So projected upwards with 100. Okay. So a beginner would start it like this. So time is asked, you know the acceleration because it's gravity, right? It's a free fall. And you know the initial velocity and you know the final velocity also. It will be the same when it strikes back, but in the opposite direction. So one will start like this. Final velocity will be minus 100 if you take the initial velocity as 100. And if you use the upward direction. Plus g will be minus 10 and then t. So answer would be 20 seconds. Any other way that you can do? Hmm? Can you do it with your mind? Yeah, I mean, when you throw it with 100, every second 10 decreases, right? So it takes 10 seconds for it to come to rest, momentarily rest. And then again, it takes another 10 seconds to reach the ground. So it's 20. So when it comes to MCQs, you need to train yourself to do like this also. Okay. We will do far more difficult question in the next class. Okay, using this method. Okay. That is not there in your Pesuru. I'll give that to you. Translate and give. Okay, now we come to the essence of linear motion. Linear motion is a chapter where you study the graphs. In and out, you should know how to convert ST graph to VT graph and VT graph to ST graph. And if they ask AT graph, same principle. Acceleration time also, same principle. Okay, so when you say graphs, so this knowledge is going to be very important for the rest of the physics. So here we say the general principle here we study is gradient of ST graph is VT graph. Then the same principle will come. Gradient of magnetic flux will be electromagnetic force. Okay, sorry, electromotive force. The gradient of electric potential will be electric field intensity. So there are things like that. So if you understand this now, you will do better in the electricity related subjects also. Okay. So now first I'll teach you about the gradient. Because here what we are going to study is gradient of ST graph is VT graph. Okay. VT graph is the gradient of ST graph when you're converting the other way. Now listen to me carefully. If we have a graph like this, it's a general graph. Okay. So this is y-axis, this is x-axis. We don't know which graph it is, but it's just a linear graph between x and y. We don't know what x and y are. Just to understand the term, we will name this as, we'll take two coordinates. We will name this one as y1, this one as y2, this one as x1, and this one as x2. Now, students, can you tell me equation for gradient m, please? Yeah. So it's y difference, y2 minus the big Y minus small y. The big is y2, small one is y1. And x divided by x difference. So it's actually a rate of change of y relative to with respect to x. That's the exact meaning. Now, if we imagine a triangle here, okay? Now we will name this thing theta. Now in this triangle, this side is what? y2 minus y1, isn't it? In the same triangle, this side is x2 minus x1. Now look at it carefully. Gradient is equal to this divided by this. Okay? That is opposite side divided by adjacent side. What do you call that in your trigonometry? Opposite side divided by adjacent side. What do you call it?
Tan.
Tan. So m is equal to tan theta. This is the principle we are going to use. Gradient is tan of theta. What is theta? Theta is the angle that the graph makes with the x-axis. You're imagining the x-axis here, okay? X-axis or the horizontal line in the positive direction. Okay, if the graph is like this is going to be the x-axis, no? This angle, not this angle. Angle that it makes with the x-axis in the positive side, positive direction, towards the positive direction, not towards the negative direction, towards the right side. Okay? When the graph is like this, you can draw the x-axis like this in the graph. And this is the angle we are talking about. The graph is like this. If you draw x-axis like this is the angle you are talking about. The graph is like this. X-axis is like this. This is the angle you are talking about. The graph is like this. Axis is like this. This is the angle you are talking about. Okay? So first define the things properly. Now you know about tan, right? You know about tan. So it's time to remember some of your tan values. So we usually study tan 0, no? Tan what? 30. We study tan 45. We study tan 60. We study tan 90 also. Can you tell me the value, students? Tan 0 is Hmm? Yeah. Hello. 0. Tan 30 is what? Huh? You have answered, no, personally. Uh-huh. Okay, okay. I didn't see those. Okay, now can you tell me tan 30, please?
1 divided by 3 root.
Yes. 45, 1. Tan 60, square root of 3. Tan 90, anybody?
Infinity.
Infinity. Ah, one maths guy here. Are you maths or bio?
No, sir. Bio.
Ah, okay, good. Then you have moved. Okay, now what you see is these are the acute angles, right? Less than 90 are called acute angles. So for acute angles, when the angle increases, the respective tan values are also increasing. You can see this is smaller than this, and this is smaller than this. Root 3 is 1.73, right? And infinity is very, very big value. So, for acute angles, for angles less than 90, when theta increases, the tan theta value is positive and it increases. This one you need to understand very clearly. When theta is less than 90, when theta increases, the tan theta value is positive. All these are positive values and it increases. In a graph, you can show it up to 90. This is how tan theta varies with theta. Don't be scared because I'm drawing graphs. Graphs are supposed to make you understand easily. Okay. But what happens is when we give graphs, students are confused. Graphs are actually supposed to be explain you the things easily. So make it easier for yourselves. So this is just showing how tan value varies with theta. Okay. Between 90 and 180, you call obtuse angles, right? So for that, I'll allow you to search the internet if you're not familiar. Tan 120, 100 and tan 135. It's not needed. Tan 150, tan 180. Just tell me for these three. 120, what's the value?
Root, root 3 divided by 2.
Minus root 3.
Minus root 3. Yes. Minus root 3. 150.
Minus 1 by root 3.
1 by root 3. 180. It's 0.
0.
So actually the graph is like this. Some people teach this in the basic math, some people don't. But it's good to know, okay? This is how the graph will be. So remember the graph, you can remember easily the values. Just reverse of this. I'm avoiding this corresponding tan 45 part, 135, but still these three values are there. Can you see? 0. It's like this, and this coming in reverse. So for obtuse angles, when the angle increases, the value is decreasing in negatives and it is becoming 0 at 180. So I will summarize that here. Theta greater than 90 when theta increases from 90 to 180. When you increase the theta, you can see this value is greater. This is smaller, this is even smaller. So tan theta is in negatives and it decreases. All right, it's negative and it decreases. Now this is what we are going to use. This knowledge, this bit of knowledge we are going to use to convert ST graphs to VT graphs. Okay, I'm going to need another page. Now, take your rough sheet and convert the ST graphs to VT graph, will you? So this is the ST graph I'm giving you like this. I think I can have. Make it smaller, no? So it's you do the first one. So now here, just focus on tan theta. The theta is the angle that the graph makes with the x-axis. Here, if you draw the x-axis is also horizontal. The graph is also horizontal. So theta is what? Is no angle that it makes. So theta
Zero.
is what? Exactly 0. So tan theta is also 0. So velocity time graph will look like this. It will be 0. So you draw along the x-axis itself. So you show the velocity is 0. Okay? You understood. Now, I'm going to give you more. Oops. Now, you can try to draw. Start doing. Only half a minute I'll give. Another half a minute. Now, here what you see is, first you have to see, I'll summarize it to you. You have to see only two things. You have to see the sign of the gradient and then the variation of the gradient. You have to first decide whether it's plus or minus. You know, if it is acute angle, it is plus. If it is obtuse angle, it is minus. And then, you know, variation is either decrease or increase or constant. That's how you describe the variation. Now, in this particular one, okay, if you draw your x-axis and see, what do you get? Is there an acute angle? Yes. Take another point and draw another line and see. Acute angle, right? This is a straight line and these two are parallel to x-axis. So these two angles are equal, right? So first acute angle, so plus gradient. What is happening to the magnitude of the angle? Plus magnitude doesn't change, right? Constant. So plus and constant. So in velocity time graph will be a positive graph, constant graph. Okay. Okay. Another time I will explain. You draw at one point and see the angle is theta, it's acute angle, so it's plus. Another point you see, it's acute angle, so it's continuously plus. And these two angles are equal, they are corresponding angles. So therefore, constant theta and tan theta. So positive constant graph. This one, how? You can answer me, you can jump and answer. I will never scold that. I actually welcome such enthusiastic people. But this one, if you draw a line in C, this angle is obtuse angle. So gradient is minus. Here also same angle, they are corresponding angles. So negative gradient will remain constant. Negative gradient constant. Okay. After this, you should not have any doubts. If you have any doubts, just ask me now itself. Now, what can you remember is if the graph is a straight line, the gradient is constant. Straight line graphs, the gradient is constant. Okay. Now, what about this? Anybody?
Velocity increases uniformly.
Plus or minus?
In plus, positive direction.
Yes, good. So here, if you draw a x-axis and see it's acute angle, so you know theta will be acute, so tan theta is positive, and you can see the angle increases, right? Right? The theta 1, theta 2, theta 3, theta 1, theta 2, theta 3 is in this order. So theta increases. You know, for acute angles, I have summarized here. When theta is less than 90 for acute angles, when theta increases, tan theta also increases. So theta increases, so it's positive. So tan theta also increases. So gradient increases. Sine is plus. The variation is increasing trend. So it will be like this. Okay. We just look at the shape of the graph. Okay. Nobody is going to ask whether it's from origin or whatever. No unnecessary questions and no waste of time. Okay. Don't think about whether it will start from origin or not. It depends on whether it's initially flat. But if it's not clear, you can just start like this. Okay. Those things are minor stuff. We don't focus on those. Okay. You said velocity increases uniformly. Yeah, but even if it is acceleration, no, it's acceleration, but increasing acceleration, decreasing acceleration, all are possible, but we prefer the simple method. So we just draw the uniform variation. We just draw the straight line. Okay. What I'm trying to say is the graph can be like this or this also, but still we prefer the simpler way. Okay. Now, have you tried this? I'll give you a few seconds for you to try. Okay. Now if you draw x-axis here, it's like around 90 degree, but still greater than 90. It's obtuse angle anyway. This one also obtuse, obtuse. This one also obtuse, obtuse. Now the angle increases or decreases? Angle
Increases.
increases, yeah. With time, the angle increases. So what will happen to tan theta?
Decrease.
Yes, very good. Decreases. We have summarized here. For greater than 90, when theta increases, tan theta is minus and it decreases. So therefore, in the graph, it should be a negative graph for velocity time and it should decrease. So how will it look like? Like this. Okay. Negative. Okay. Negative, decreasing. This is how you draw negative decreasing trend. Okay. You are studying all the shapes. So nobody is going to ask anything new. There is nothing new if you have studied everything. Okay. Okay. Can you? Now here it is. What type of angle it is? What type of angle is this? Hmm. It's obtuse and the angle decreases, right? You can see this is bigger, smaller, smaller. So when angle is obtuse, it's minus gradient. And when the angle decreases, it's decreasing. So gradient will, tan theta will increase. So in negative values, it will increase. So it will look like this. Okay. So this one, this angle is acute. And you can see the angle getting smaller. So theta is decreasing, right? Tan theta will be positive. Therefore, when theta decreases, tan theta also decreases. So gradient will decrease in positives. Gradient will decrease in positives. So Vt will decrease in positive. Okay. So we have studied all the possible shapes. Okay, even if they give a circle, which is not possible, all these shapes will be incorporated. You have studied all these shapes. Now you can't miss any question from graph. Okay. Okay. Now I will give you some questions. So can you try for these and come when you come to the next class? Remind me, okay, if I give any homework. You have to convert ST to VT. Okay, take a screenshot and keep. You have to do and come. Started the recording, right? And students, whenever I teach, please tell me if I'm not starting the recording, because it will cost a lot if we don't start the recording and just keep discussing. It's like losing something very precious. The recording is very important. Okay. Okay, now we will discuss some questions before we wind up. Okay, now this is reverse VT graph to ST graph. If the velocity of an object varies with time t, as shown in the figure A, the corresponding variation of the displacement with time t is best represented by. Can you put the answer in the chat? Okay. Now you have to think like this. Velocity is the gradient, and here this tells us about the gradient of ST graph. Okay, this is the gradient of ST graph. So initially, up to the time t1, it is plus and constant. Okay, students. So gradient should be plus, so angle should be acute angle and constant. Okay. So what are the answers you can eliminate? This one won't come, second one won't come. Second one is a curve. Third one, there is no graph. Others are okay. Now, this part, the mid point from T1 to this midpoint. So it's positive and decreases. So gradient should be positive, so it should be acute angle, and it should decrease. So what is the gradient decreasing pattern? This is the gradient decreasing shape, right? And it comes to 0, so it should be flat at the end of it. So it will be coming like this. At this point, it should be flat. Okay, velocity will be 0. Okay, so fourth one won't come, fifth one also won't come. That variation is not to be seen. But here you can see, so that's the answer. But if you keep on explaining, here velocity is negative. So gradient should be negative. So the angle should switch to obtuse. Initially it was acute, now it should be obtuse. So now you can see in the first graph, it's like this. Okay. So up to that peak, it's decreasing angle, acute angle, and it becomes 0 here. And after that, you can see obtuse angle. And it's decreasing angle, so gradient is increasing. So in the negative, gradient is increasing, right? And here from T2 to T3, okay, negative gradient constant. So obtuse angle constant. So first one. Okay. First one is the correct answer. Okay. Now this needs a good understanding of describing the graphs. The two straight lines shown in the displacement D versus time graph represent the motions of two objects A and B started from rest at same time t is equal to 0 and moving along the positive x direction. Which of the following statements made about the motions of the objects is true? Okay, so we will go one by one. The object A has traveled longer time than B. Is that correct? Anyone?
No. No, sir.
No. Because from time 0 to t0, both of them have traveled. Okay, this is not even a good statement. I mean, okay, it's obviously wrong statement. Second one, when time t is, I'm saying it's not good because it's too easy. Okay. Second one, when t is equal to t0, the object B has more displacement than. That's the problem with Pesuru. See, object B has made a displacement greater than A. It's false. What you see is A has a greater displacement. It's the displacement axis. What you see with your eyes is A has a greater displacement. So wrong. Third one, object A has a greater velocity than B. That's correct?
Yes, sir.
Yes. So velocity is given by the gradient. Gradient is tan theta of the angle. So if you compare both are uniform velocities, if you compare this angle with this angle, B makes a small angle, means smaller gradient, means smaller velocity. So statement 3 is correct. A has a greater velocity. Statement 3 is correct. What about fourth one? Object, great acceleration, false. Both of them have no acceleration. Acceleration is just gradient of velocity. Because these are uniform velocity, there is zero acceleration. So fifth one, both objects have same velocity at a point. Those two straight lines cross each other? No, they have different velocities throughout. Now tell me what is happening at this point of intersection?
Both are at the same location.
Yeah, they are meeting. Both are at the same location. Okay, I'll tell you another statement. Both are moving in the same direction. Is that correct?
Yes.
Yes, both of them have positive gradient, means same direction of velocity. Okay, good. You have understood it clearly. Now, this question. Can you try the answer? Put it in the chat or you can tell if you want. Graph shown in the figure represents the velocity v versus time t curve for an object. The corresponding displacement time curve is best represented by. All right. So this one velocity time graph. So velocity is the displacement, is the gradient of the displacement time graph. So initially velocity is plus and it is decreasing. So positive gradient should decrease. Which graph? It's in the second one. First one is wrong, fourth one is wrong, fifth one is wrong. Second and third, the first half is correct. And then negative, it's increasing. Sorry, it's increasing in negatives. You can see 0, -5, 10, 20. Like that I can tell, for example. So it's increasing in the negative side. So obtuse angle should decrease. You know? So here you can see in the third one, the initial half is correct. And then it still remains the acute angle, positive direction. But here in the second one, initially acute angle, second half is obtuse angle. So that tells you it's two different gradients. Here positive, here negative. So second answer is the right answer. Third answer is wrong. Okay. Now a tricky question for you. Let's see who answers or whether you answer correctly. So now identify the moments where the directions of the displacement, velocity, and the acceleration change. So it is ST graph given, and you have to identify the times or moments where direction of the displacement changes, where the direction of the velocity changes at which times, and acceleration changes. You can maybe draw a graph, velocity time graph, and then acceleration time graph to make it easier for yourselves, or just by looking at it, you can answer. But I would suggest you to draw velocity time graph and acceleration time graph. So first question is easy. When does the displacement change its direction? You can see obviously at T2 from positive displacement. At T2, positive displacement becoming negative. After T4, there is no motion, so we can't say T4 as an answer. But for first one, obviously T2 is the answer. What are the times where velocity changes? Can you try that? I'll come in 2 minutes or 5 minutes. Okay, did you guys draw the velocity time graph? We will draw, no? That will help us to refresh the knowledge also. So I'll duplicate it, keep it here. I'll draw velocity time graph just below it so that I can compare the time frames. And acceleration time graph just below it so that I can compare the time frame. Okay, so this is going to be Now from here to here, you know, it's positive gradient decreasing and becomes zero here because it's flat. So positive gradient decreasing and becoming zero means velocity decreasing and becoming zero. And then here what happens? Negative gradient. What? Could you tell me? Increases. Here, students, hello. Are you with me?
Yes, sir.
Yeah. What do you see there from? Sorry, I'm sorry, ChatGPT. Okay, it's what positive, right? Sorry, what angle is this? You just look at the angle. Don't worry about this going negatives in displacement. It's the negative side of the displacement graph, but we don't worry about that. We worry about the angle. Obtuse angle, yes. Increasing, yes. So negative gradient will decrease. And here it's flat. What does that tell you? It decreases and becomes zero. Here, from T3 to T4, zero, and then gradually the acute angle increases, right? It's like this. So you draw like this. So in the VT graph, wherever you have the graph going from positive to negative or negative to positive, whichever the way, if it goes from positive to negative or negative to positive, the direction changes. That is the meaning of positive and negative, right? So here you can see it's positive and then it goes to negative. So the velocity changes the direction at T1. Where else? Where else?
T3.
Very good, T3. T3. Okay. It changes the direction at T1 and T3. Whereas the acceleration changes the direction. For that, you have to draw the acceleration time graph. Acceleration time graph is gradient of the velocity time graph. Just like you converted ST to VT, you have to convert VT to AT. So initially, throughout this period, velocity changes direction here, but it's a straight line. So constant acceleration, positive or negative gradient?
Negative gradient.
Yes, because it makes a obtuse angle. So negative constant. Okay. Here, acute angle is constant. So positive constant. So where does the acceleration changes the direction? T2. Negative to positive. Okay. That's how we understand these directions. Yeah. The next thing is projectile motion. I am not going to explain the theory, but you need to know projectile motion, you are throwing an object with an angle. So the velocity will have a vertical component and a horizontal component. So you describe two types of motions. You use the equations in two directions separately. Okay. So one motion, vertical motion, is a free motion under gravity with constant gravitational acceleration. Horizontal motion has no resultant force in the horizontal direction, so acceleration is not there. So constant velocity in the horizontal direction. Provided that what should be negligible?
Drag force.
Very good, air drag. Okay, air drag should be negligible so that horizontally there is nothing. I'll teach you the effect of drag forces later. Okay. So you know the answer, right? It's finishing there. So when it comes to the fall under gravity, you throw it with vertically with a uniform velocity, initial velocity. It will go here and come to rest and then come back. So there the direction of the velocity changes. Acceleration is constant downwards. So initially the upward velocity, we take it as positive. It decreases uniformly and becomes 0, and downward velocity, the opposite direction, increases. So this will be the PT graph. Okay. Let's say like an object is freely dropped like this, goes and hits the surface and comes up to a small height due to the loss of energy during the collision. What will be the VT graph? Bro? Come on, it's not difficult. They have done, just tell me. Done.
Done, sir.
Done.
Okay. So now you're dropping from rest, right? The velocity increases and reaches the highest velocity just before it hits the ground. And then immediately the direction of the velocity, initially downwards, becomes upwards. And so the direction switched to the opposite. Yeah. Then it starts again moving upwards with initial velocity and comes to rest finally. But what do you think? Is the collision velocity same as the returning velocity? I told loss of energy. So kinetic energy is lost, the velocity will be reduced. So smaller velocity come like this. Okay. You can see the graph's area gives you the height or the displacement. So for the initial half, it's greater. The later half, it's smaller. Okay. All righty. Okay. What do you think? These two graphs will be parallel. Huh? Huh?
Yes.
Yes, because same gradient should be there because same acceleration throughout. It's always downwards G. Gravitational acceleration is always downwards. So it doesn't change the direction. Okay. So the lines should be parallel. Okay. Now I'm going to give you a question. So it is the second question I'm giving you. First question I gave you some graphs. I think already we have covered those when we did the past paper questions, right? These are past paper. And in this one we covered one. Okay. Whatever, what you do. Now the next homework is, it looks complicated, but it's easy. Okay. See how you do. We will see how you do. Okay, a ball X is thrown. And then after that, along the same line, X has gone up. Okay. After 2 seconds, again, Y is thrown along the same line. Okay. So when time is equal to 0 for Y, X would have traveled 2 seconds because it's thrown 2 seconds before Y. Now, the question is, what is, because they are in the same line, they will meet at some point. What is the velocity of the balls? They will have same velocity. That's why we are saying velocity of the balls when they meet. Write it down, write it down. What is the distance from the highest points, from the highest point X reached when they meet? I mean, X would have gone to highest point and come. Now Y will come and they will meet. No. So this is the meeting point. I'm asking you, what is the distance of the meeting point from the highest point that X has ever, okay, X has ever reached to? All right. Okay. Give me 1 second. Hello. Hello. What's up? Okay, do and come. Huh? Do you have any questions? Okay. Next class we will do on Sunday. So you will have time to do the past paper questions. No excuse, huh? If you don't come, don't do and come. If you don't do and come, I might scold you. Who knows? Okay. Any questions? Okay, thank you.